about similar figures. You'll learn, this is kind of an intro into what you'll see in geometry someday, with similarity. So similar figures, they can have the same shape. Oops. But they'll have a different size. So they're not equal figures, they're similar to each other. They're proportional to each other, okay? The way we mark similarity is with a little tilde. So we would say, is similar to, whenever you see this little mark, okay? It's that on a keyboard, it's the top left corner on your keyboard. So, for instance, if we said something like this, triangle ABC is similar to triangle FGH, and I gave you these two triangles. Do you hear that ringing?
Yes. You heard
Okay.
too? I was like, one going crazy.
Oh, it quit. Okay, so triangle ABC is similar to FGH. Notice they're not the same size, right? They're different sizes. This is 8, 10, and 12 for their lengths. This is 12, 15, and 18 for their lengths. Okay? But what you need to notice about these is a couple things. First of all, their angles will be the same. So their angles are going to match up. Elijah, what are you doing over there? Yeah. Pay attention to this. So if your angles are congruent, okay, they're similar figures, but your sides aren't going to be congruent. Your sides are going to be different lengths. So yes, angle A, this symbol, the equal sign with the tilde, that means congruent. That means equal to. So angle A will be congruent to angle F, and angle B will be congruent to angle G, and angle C will be congruent to angle H, okay? So all of these, is congruent to. Okay, so they're equal, okay? That's the angles, but the segments have to be proportional. Do you know what a proportion looks like?
It looks like something special.
I know what it looks like.
What makes up a proportion? Anybody? Okay, so proportion is pretty much saying ratios are equal to each other. So something over something equals something over something, right? That's a proportion. So what we're going to do for this is we're going to compare the parts that match up. So AB, right, that's the first two letters of our triangles. That corresponds to the first two letters over here. So we're saying AB corresponds to FG. So we're going to put 8 over 12 because those are the ones that match up. Okay. If we set that equal, we set up a proportion for it, then we could say AC. Okay, so A and C are the first and the third letters. You need to match it up with the first and the third letters over here. So FH is this guy, the 15. So we're saying 10 over 15. Okay, so what's my last ratio then? Right, you're doing 12 over 18. And here's the really important thing about this. You have to go in the same order. So if I'm going smaller to bigger, I need to go smaller to bigger on every single one of them. Okay, or left triangle to right triangle. I need to go left triangle to right triangle on every one. Okay, so here's the beauty of this. They told us these were similar, which means these ratios should all be the same. What does 8 over 12 reduce to?
6 over 9.
I think.
4 over 2.
No.
6 over 9, I thought that was correct. It could reduce to that.
Not 4 over 5.
6.
2 over 6.
2 over 3, right? If you divide, right?
2 over 3, right? Right.
Which is 6 over 9. You just, I don't know how you reduced yours, but you have the right, yours would reduce to the same thing, Kennedy.
Oh, you just reduced it again.
Right? So if I divide top and bottom by 4, right? 8 divided by 4 is 2. 12 divided by 4 is 3. Okay? Then move on to the blue one, 10 and 15. If I divide both of those by 5, 10 divided by 5 is 2. 15 divided by 5 is 3. And then 12 and 18, both of those are divisible by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So what you notice is while they all look different to start, they're actually all going to reduce to the same thing. They are similar figures. Okay, so as long as they get the same ratios, they are similar figures. So here's what you're going to have to do with that. This one I gave you all the numbers, but sometimes you're going to have to find one of them. Okay, but if we know they're similar, that's very doable. So example 1. Let's say I tell you triangle ABC is similar to triangle DEF. Okay, I want to know what the length of DE would be. Okay, so we're going to find DE. So here's your two triangles. And it's important where your letters go because that's how you know what matches up. So 10 and 16. And then this one is 18. This is D, E, and F. And this is 12. Okay, so it's really easy on these to look at the numbers and go, oh, 10's smaller, so that must go with the 12, and 16's bigger, so that must go with the 18. But that's not how it works. You got to match up the corresponding parts. So right now I have AB, right? And AB is 10. What does AB correspond to on the other triangle? DE, right? The first two with the first two. But we don't know DE, but that's what we're trying to find. If we don't know something, but we're trying to find it, what do we call it? Pick a variable, right? Call it X, call it Y. You can call it whatever you want, just give it a variable. So if we call this X, I would say right now that 10 corresponds to X. So I'm going to put 10 over X. Okay? Now we're going to set up a proportion. We have to figure out what number corresponds to what number. So you can look here. You have BC, so that's the second and third letter. That would have to correspond over here to EF. How long is EF? 12, right? So you have 16 and 12. You're going to set that up here. 16 over 12. Okay, so this is a proportion. What do you do to solve that proportion? Cross multiply, right. So you're just going to cross multiply this. You get 16 times X equals, and then 10 times 12. And then we'll simplify. So it's going to be 16X equals 120. And then you're going to divide by 16. And X comes out to 7.5. So they asked, what is the length of DE? DE has a length of 7.5 because that's what we were solving for up here, right? That X was our DE. Okay, so it's just setting up a proportion. Questions on that? If they don't ask you to find AC, then you don't have to. Yeah, you could right now, right? You could set up the proportion and solve for that, but we don't need to. Adria, will you do me a favor? Will you pull that air freshener out? Too much. Thank you. Okay. Second example is indirect measurement. Okay, and this is something that you could actually use on a regular basis if you needed to know the length of something or the height of something and you didn't have a great way to measure it. You could use what's called indirect measurement. So this is example 2. And here's what it says. The sun's rays strike a building and a girl at the same angle, forming two similar triangles. So here's a girl. Okay, here's a building. They're both on the ground. Okay? So here's the deal. the sun coming down on them is forming an angle that's the same in both of these. So what happens is we end up with two triangles that are similar triangles. Okay, so we have these two triangles that are similar. If we know the girl is 5 feet tall,
She's 5 feet tall.
and then we measure her shadow as 3 feet, okay, and we want to know how tall is the building, so that's going to be our x, but we can measure the building's shadow as 15 feet. Okay, well, because they told us that we created similar triangles, the sides have to be proportional. So can you tell me what proportion you could set up? What over what equals what over what? Three over 15, right? So it's going to be shadow over shadow equals height over height. Okay, so 3 over 15 equals 5 over x. Now here's the question. Could I say 3 over 15 equals x over 5? You have to go in the same order. Could I say 15 over 3 equals x over 5? That one you can do, okay, because you're going in the same order. Bigger to smaller equals bigger to smaller, okay? So as long as you go in the same order, you're fine. Just make sure you're going in the same order, okay? So we set this up and we cross multiply. We get 3x equals 15 times 5 is 75. So then we're going to divide by 3. And you get x equals 75 divided by 3 is 25. 25 what? Feet, right? You want to keep the units that you're working with. So 25 feet. So that means this building is 25 feet tall, which you wouldn't be able to measure just standing there, right? But you can measure it because you know its shadow, and you can measure its shadow. Okay, so that's called indirect measurement. Questions on that? Yeah. After I finish the lesson. I got 2 more, and then you can go. Okay. That's not what I wanted. These last 2, that's what I want. You have, and I'm just pulling this out of the book so that you can see the picture that they're using. You have this map, okay? And we're going to be talking about scale drawings. And maybe you've looked at a map before, maybe you've looked at blueprints for a house before, but those are using scale drawings. So you can't draw a map the size of what you're drawing, right? If I wanted to draw this building, I wouldn't draw it as big as the building, or that defeats the purpose. So what we do is we scale it down, but proportionally. So everything's going to be proportional to what we started with, okay? So like here, you get, it says, what is the actual distance from Jacksonville to Orlando? And they give you a ruler, okay? So how far on that ruler is that? How many inches from Jacksonville to Orlando? It's kind of tricky because you would assume it's 1.5. But here's your halfway mark here, right? Each of these little hash marks would be a quarter of an inch. So it's 1 1/4 inches from Jacksonville to Orlando, right? It's 1.25 inches. Okay. I want to know, how far is that in actuality? Do you see anything on this picture that will help you figure that out?
Yes, we do.
What? The scale, right? They tell you
According to my calculations.
that, thank you for calculating. They tell you that 1 inch is 110 miles. Well, we went 1.25 inches, right? So what you're going to do is inches to miles would have to equal inches to miles, right? So if I know 1 inch is 110 miles, then 1.25 inches has to be some number of miles. What do you do from there? You cross multiply. So we're going to do 1 times x is just x. And then 110 times 1.25 is 137.5. Okay, now here's where it's a little bit tricky at times. 137.5 what? Inches or miles? Miles, right? If we were going inches to miles, miles is our unknown. So it's 137.5 miles from Jacksonville to Orlando. Okay, so it's just a scale drawing. You take the scale they gave you and you set it up as a proportion. Questions on that? Okay, last one. Did you say wait? For this last one, it's another scale drawing, but using a human heart. Uh-huh.
Yes. Human anatomy.
Okay.
Stop, I like it. It makes me cringe. I don't stop.
Why? It's not a real, it's just a picture of, it's not a real heart. It's a picture of one. Excuse
I'm
me.
glad that a heart only can 14.
Ew, I hate looking at the blood veins.
Okay, well, just don't look. We'll talk through it. So it says a giant model heart is shown below. The heart is the ideal size for a person who's 170 feet tall. So if there was a 170-foot tall person, their heart would be 14 feet large, tall.
You know, Will Well's heart is the size of a Mini Cooper of a car.
Is it really?
Yeah.
That's cool. Okay, so what they're saying is this person, if this was his heart, right, he would have to be 170 feet tall.
14 feet.
Okay? It says about what size would you expect the heart of a man who's 6 feet tall to be? Okay? So we're saying a 170-foot tall person would have a 14-foot heart. A 6-foot tall person would have how large of a heart? What's your proportion?
2 inches.
Someone's as big as
I'm 6 feet tall.
someone's as big
And I
as
think 2 inches.
Okay.
Well, how about we do the math and we'll figure it out. So what over what equals what over what? Right? We're going to set up a proportion.
Why do hearts look like that?
Wait, Miss.
I don't know.
When you draw pictures like that.
I know. They wanted to make it look nicer for what an actual heart looks like.
So if somebody was 5 feet tall, would their heart be smaller than a 6-foot person?
Oh my gosh.
That's essentially what they're saying is it's proportional to your size.
Well, yeah, a baby's heart.
Yeah, so if you think about a baby's heart versus our heart, they say your heart is usually about the size of your fist.
Oh my goodness, remove it.
Yeah.
Explains a lot.
When we finish this.
Pretty big heart.
Okay, so here's the setup, right? You're going to say heart to man equals heart to man. Or technically, you could say heart to heart equals man to man. You just need parts to correspond, okay? But we're going to go heart to man. So heart to man. Okay, so hearts are on top. The man is on bottom, okay? So what's going to go on top over here? On the right side. If we're going heart to man.
So it's the feet to.
Well, they're all feet though, right?
Yeah.
So what's on top, the heart or the man?
Yeah.
The heart, right? You want to correspond the same thing. So heart to man, x to 6, equals heart, which is 14 feet, to the man, which is 170 feet. Okay? So make sure you're matching things up. You cross multiply that. 14 times 6 equals 170x. And 14 times 6 is 84. So you're going to divide by 170. This is gone. And you get 80 divided by 174. So you get 0.49 feet. Okay. So what's that close to? 0.49? 0.50. 0.5 is half of a foot, right? So this comes out to about a half of a foot for the size of your heart, or a 6-foot man's heart, size of Nathan's heart. Okay? Questions on that? Okay. You have about 10